Okay, so as I mentioned, the whole point of learning how to get the remainder of 0 to test for is so that we can factor things beyond x squared. So I'll show you how the procedure kind of works. In this first example, we have a polynomial, which this is something new, right? We don't deal with cubics. So show that x minus 2 is a factor, and then determine the remaining factors. This is the process that we're going to do. Basically, if we know one factor, then we can try and find the others. So if we want to show that that works as a factor, the value I'm using is 2. So 2 cubed plus 5 times 2 squared minus 2 times 2 minus 24. That's going to be 8 plus 20 minus 4 minus 24, which is 0. So there's 28 there and minus 28 there. Okay, so I know it's a factor. And here's what we're going to do to figure out how to get the rest of the polynomial factored. We're going to use the division that we had before and find out what's left over once I take this factor out. The idea is kind of like saying, if I know that 5 is a factor of 60 and I wanted you to factor it, the problem then becomes 5 times what's left over? 12. We have to factor this, which would be 3 times 4. So you would get 5 times 3 times 4. And yeah, the 4 could be factored, 2 times 2. So it's just showing you how we're trying to break the problem down. We're going to do the same thing with the polynomial. So it's a little strange because we're dealing with x's instead of numbers, but here's how it works. Yeah, we can use synthetic division. That's a good shortcut. So my polynomial is 1, 5, negative 2, and negative 24. The number here will be a 2. So it'll be 2 times 1 is 2. Add them together, 7. 2 times 7 is 14. Add them together is 12. 2 times 12 is 24. And that's a 0. Now, how do I know ahead of time that that must be a 0? We already found the remainder here, right? This is the remainder. Whoops, sorry. This is the remainder that we already found. So this tells me it's going to be x squared plus 7x plus 12. Remainder was 0. And that's what we expect. If you don't get a 0 when you know it's a factor, you made a mistake in your division. Okay? So what's left over? X squared plus 7x plus 12. Well, I can factor this. That's something that we're used to doing, so it'll be easy to just do it without needing any extra tricks. So here are the 3 factors. One of them that we were given, and the other 2 that we found. So completely factored, it'll be x minus 2 times x plus 3 times x plus 4. Okay, so your turn. See if you can follow that procedure. Factor this one completely if you know that this was given to you as one of the factors. Okay, so you know, it's not always necessary. If you're told it's given, then you don't need to verify that it was a factor. We're going to do it anyways by synthetic division. So 2 here, 1, 2, negative 5, negative 6. And what I end up getting here, it should be a 0 because it tells me it's a factor. Otherwise, something went wrong. So I'll do the synthetic division. 2 times 1 is 2. Add them up is 4. 2 times 4 is 8. Add them up is 3. And 6 goes here. So everything worked as planned. That means what's left over is x squared plus 4x plus 3. Or x plus 1 times x plus 3. So completely factored, this would be x minus 2 times x plus 1 times x plus 3. Okay. Any questions about this business of factoring? So now the question becomes, how do we factor if they don't give us the first one to start with? Like what we did here, it was given, and up here we were also given what to use. So let's take a look at a strategy here for finding a factor if we're not told. Okay, so what we're going to take a look at is this idea of how do we work backwards and try to figure out where the roots came from. So if this was our question, we call these the roots because remember when we did parabolas, these were the zeros where the graph equaled 0. So 4 minus 4 is 0. So 0 times anything, the whole function equals 0. Negative 3 plus 3, same idea. So we end up with a value of 0. The product of these roots is negative 12. Okay. Over here on this side, we can verify again. This is negative 5, negative 2. The product is 10. Anybody seeing a pattern here? Yeah. Now, where are you seeing these numbers? Sure, Connor.
The product of the roots is equal to the last number in the...
Yeah, we're finding that constant term by doing it. So let's go up another one higher. This is 1, negative 2, and 3. So multiply them together is negative... Oops, did I make a mistake there? 1, negative 2, negative 3. Pardon me?
Oh, that's weird.
Well, this is to illustrate a point for you. There is not actually a mistake here. This is correct. I'll explain why in just a second. But let's take a look again here. This will be 2, 5, negative 3.
It's negative 30.
Which is negative 30. So it became negative. But so far, it's similar to the pattern, right? It's similar. The number's there. But it could be the positive or the negative of the number. Do you know why?
Because there are 3 now.
It may not be that there's 3. Do you want to try and explain?
It's a cube.
Again, it may not be because of the cube. We may have it if it was to the 4th, something else. It has to do with the fact that these roots we're saying is we're looking at where 0. So whether it was plus or minus really doesn't change the fact that it's 0, right? So positives and negatives still end up with the same value. If it's positive 0 or negative 0, they're just 0. Okay, so factor theorem, if a polynomial has an integral root, this just means integer. It must be a factor of the constant term. And what we have to keep track of is use both the plus and minus factors. Because we don't know where our search is going to take us, if it's positive or negative. Okay. So, let's take a look. What search would we be doing? If this was our polynomial, where would we search for a root? What would be a good candidate? Can someone give me one candidate that would make sense? Sure, Alice?
Negative 1, 3, 5.
Oh, okay. So there's actually one more. There's one more factor. It's really, it's hard because it's an obvious
15.
one. 15, yeah. So, but like I had said, make sure you're doing both the positive and negatives. Because when we start off here, there's a negative 3, but we don't know that that's going to be one of them from the original number. So we take both the positives and the negatives. Okay, so what about for 72? What numbers could I use for 72?
8.
Yeah, so I was thinking 1, being simple. 8 will work. What else?
2.
2 will work.
9.
9 will work.
3.
3.
4.
This is bad.
And
12.
12 will work. Yeah, 72 is going to be in there. There's another one still before it, I think.
36.
So 36. There should still be something in there.
24.
24, yeah.
And 18.
And 18, yeah. We missed an 18. And 72.
Wow. Wow.
So plus or minus for each of them. So, you know, I'll try to be nice to you and not make you search through 300 different numbers, right? But it still looks bad, but I got to tell you, you still know the answer has to be one of those. So at least if you've limited it down, you know it's got to be there. It's not like you're just randomly hoping the number you guess will work. The number will be one of those when we check. Okay?